we want to simplify the following expressions. We first have x to the third y to the sixth raised to the power of negative 5. To begin simplifying, we'll first apply the power property of exponent shown here. A raised to the power of m raised to the power of n equals a raised to the power of m times n, which means when we have powers raised to powers, we multiply the exponents. So x to the third y to the sixth raised to the power of negative 5 is equal to x raised to the power of 3 times negative 5, y raised to the power of 6 times negative 5. So this is equal to x raised to the power of negative 15, y raised to the power of negative 30. However, we need to express the simplified expression using only positive exponents. So now we'll apply the negative exponent property shown here. A to the power of negative m equals 1 over a raised to the power of positive m. One way to help remember this rule is to write a to the negative m as a fraction with the denominator of 1. From here, if we move a to the negative m down to the denominator or across the fraction bar, it'll change the sign of the exponent. So applying the exponent property to x to the negative 15, y to the negative 30, let's first write this as a fraction with the denominator of 1. And now if we write this with both bases in the denominator, the sign of the exponents will change. So this is equal to 1 over x raised to the power of positive 15, y raised to the power of positive 30. Looking at the next expression, notice how we have this fraction raised to the power of negative 5. Let's first simplify the fraction before raising it to the power of negative 5. Looking at the fraction, notice how we have two quotients here. We have a to the negative 5 divided by a to the negative 2, and b to the negative 2 divided by b to the negative 5. So because we're dividing and the bases are the same, we'll apply the quotient property of exponents shown here. A to the m divided by a to the n equals a raised to the power of m minus n. So when dividing and the bases are the same, we subtract the exponents, and it's always the exponent of the numerator minus the exponent of the denominator. So inside the parentheses here, a to the negative 5 divided by a to the negative 2 is equal to a raised to the power of negative 5 minus negative 2, and b to the negative 2 divided by b to the negative 5 is equal to b raised to the power of negative 2 minus negative 5, and all this is still raised to the power of negative 5. So here we have a raised to the power of negative 5 minus negative 2 equals negative 5 plus 2, which is negative 3. Then we have b raised to the power of negative 2 minus negative 5, which equals negative 2 plus 5, which equals 3. Again, all this is raised to the power of negative 5. So now we apply the power property of exponents. Because we have powers raised to powers, we now multiply the exponents. So this is equal to a raised to the power of negative 3 times negative 5, b raised to the power of 3 times negative 5. So we have a raised to the power of positive 15, b raised to the power of negative 15. So notice how the a does have a positive exponent, but the b doesn't. So as a fraction, we would have a denominator of 1. And from here, if we move the base of b down to the denominator, it will change the sign of the exponent. So the a to the 15th stays in the numerator, and the denominator would be b raised to the power of positive 15. I hope you found this helpful.